Hi, I'm Mr. Hassan, and we're here with the 10th installment of our flipped classroom. Today we're going to be covering lesson 3.10, problem solving the coordinate plane. We're only going to need our textbooks today, and your classwork should be in your practice book. So again, we're going to start in our textbooks, chapter 3, lesson 10, on page 135. I'm going to refocus the book, and I'll see you guys in a minute. Alright, so here we are on page 135, chapter 3, lesson 3.10, problem solving the coordinate plane. Let's read under Unlock the Problem. An artist is using an illustration program. The program uses a coordinate plane with the origin 0, 0, located at the center of the computer screen. The artist draws a dinosaur centered on the point 4, 6. Then she moves it 10 units to the left and 12 units down. What ordered pair represents the dinosaur's new location? Use the graphic organizer to help you solve the problem. I'm going to slide my textbook up here, and I'm going to refer back to the problem. So you may need to look back up at the paragraph to find some of the information that we're going to go over, but I'm not going to recenter the book, so fair warning. Okay, so what do I need to find? I need to find the blank for the dinosaur's new location. I need to find the ordered pair. The dinosaur started at the point blank blank. And again, if I look back up in the text, I can see that the dinosaur started at points 4, 6. Then the artist moved it blank to the left and blank down. Well, the artist moved it 10 units to the left and 12 units down. How will I use the information? I can draw a diagram to graph the information on a blank. It's going to be coordinate plane. Solve the problem. Start by graphing and labeling the point blank. That's going to be 4, 6, where the dinosaur was started drawing. So let's go over and look at our coordinate plane and graph 4, 6. So I'm going to go right 4 and up 6. And there's my starting point. So I think I'll call this just SP for starting point. From this point, count blank units to the left. Well, I'm going to go 10 units to the left. Then count blank units down. Well, it's 12 units down. All right, so here I go. Let's see. I'm going to go 10 units left. 1, 2. Oh, wait a second. We're going to count in intervals of 2. Almost missed that. Here we go. So I got to go in intervals of 2, 10 units. So 2, 4, 6, 8, 10. And then 12 units down, again in increments of 2. So 2, 4, 6, 8, 10, 12. Graph and label the point at this location and write its coordinates. Well, the coordinates are going to be -6 on the x-axis and -6 on the y-axis. So -6, -6. And then if I slide my book up here a little bit further, I can read that last problem. It says, so the dinosaur's new location is -6, -6. All right, I'm going to turn the page and we'll take a look at another problem. See you guys in a minute.
Whenever I'm with you
Okay, so here we are. Try another problem. Tyrone and Kyra both walk home from school. Kyra walks 4 blocks east and 3 blocks south to get home. Tyrone lives 3 blocks west and 3 blocks south of the school. How far apart are Tyrone and Kyra's homes? Use the graphic organizer to help you solve the problem. So again, I'm going to slide my textbook up, but you may need to look back at the word problem to help you follow along. All right, read the problem. What do I need to find? Well, let's think about that. We need to find the distance from Tyrone's home to Kyra's home. So again, I need to find the distance from Tyrone's home to Kyra's home. What information do I need to use? So again, if I look back in the text, I know that I need to find, or I need to use that Tyrone and Kyra start at the same point. Kyra walks 4 blocks east and 3 blocks south. Tyrone walks 3 blocks west and 3 blocks south. So let's see. I wonder if I can simplify that a little bit. Kyra walks 4 blocks east and 3 blocks south. Tyrone walks 3 blocks west and 3 blocks south. How will I use this information? Let's think about this. I guess we can use a coordinate plane with the school as the origin point. Then I can trace each student's walk home and mark where his or her home is. Then I can determine the distance between their homes. So let's see. How am I going to do this? So let's say that the school here is the origin point. So we'll label this SCHOOL for school. Kyra walks 4 blocks east. So let's say each one of these units here equals 1 unit. So Kyra's going to walk 4 blocks east. 4 blocks east. 1, 2, 3, 4. And then 3 blocks south. 1, 2, 3 blocks south. So again, I went east and then south. We could call this, I should have labeled this, we could have called this north, south, east, and west, just like a map. So again, I went 4 blocks east, 3 blocks south. Tyrone starts here at school and goes 3 blocks west, 1, 2, 3, and 3 blocks south, 1, 2, 3. Let's call this one T for Tyrone, and we can go back and label this K for Kyra. So how will I use this information? Again, we went back and it looks like we put the school at the origin. Then we labeled north, south, east, and west using the X and Y planes. Then we graphed the students' homes. So the question is now, how far apart are they? Well, this one's actually a little bit easy because it looks like they're on the same axis, right? These are both going to have which numbers be the same? Is it their x-axis numbers or their y-axis numbers? Well, they're both down 1, 2, 3, it looks like 3 south. So they're both going to have the same y-axis numbers, so we can just count across our x-axis to find out. So let's see. 1, 2, 3, 4, 5, 6, 7. So they're going to be about 7 units apart. Slide up here a little bit so we can answer this last question. So it is blank blocks from Tyrone's house to Kyra's house. 7 blocks. Describe the advantages of using a coordinate plane to solve the problem like the one above. Well, in my thought about this is it makes it easier to visualize. You can actually see what's happening, and you don't have to so much picture it in your mind's eye. So for me, I would say an advantage would be using the graph or using the coordinate plane allows you to visualize the data. All right, I'm going to refocus my camera, and I will see you guys on the next page, page 137. See you in a minute.
You and 9 other individuals have been captured by super-intelligent alien overlords. The aliens think humans look quite tasty, but their civilization forbids eating highly logical and cooperative beings. Unfortunately, they're not sure whether you qualify, so they decide to give you all a test. Through its universal translator, the alien guarding you tells you the following. You will be placed in a single file line facing forward in size order, so that each of you can see everyone lined up ahead of you. You will not be able to look behind you or step out of line. Each of you will have either a black or a white hat on your head, assigned randomly, and I won't tell you how many of each color there are. When I say to begin, each of you must guess the color of your hat, starting with the person in the back and moving up the line. And don't even try saying words other than black or white, or signaling some other way, like intonation or volume. You'll all be eaten immediately. If at least 9 of you guess correctly, you'll all be spared.
You have 5 minutes to discuss and come up with a plan, and then I'll line you up, assign your hats, and we'll begin.
Can you think of a strategy guaranteed to save everyone?
All right, share and show on page 137. Number 1, Busby County is rectangular. A map of the county on a coordinate plane shows the vertices of the county at -5, 8, 8, 8, 8, -10, and -5, -10. Each unit on the map represents 1 mile. What is the county's perimeter? First, draw a diagram of Busby County. So let's take a look at this and let's graph some of these points. So the first point says -5, 8. So I'm going to come left -5, and I'm going to go up 8. There's my first point. My second point says 8, 8. So I'm going to go right 8, and then up 8. My next point says 8, -10. So I'm going to go right 8 and down -10. And my last point says -5, -10. And I can roughly, I probably should use a ruler to do this, but I can roughly trace out the perimeter of Busby County. Next, use the diagram to find the length of each side of the rectangle, then add. Well, let's see. Well, let's call this the length, and this side up here is going to be the length. And we'll count. So remember, each unit here is 2 units. So 2, 4, 6, 8, 10, 12, and then plus 1 is 13. And this line down here is going to be the same, so it's going to be 13 plus 13 equals 26 units. And that's going to be what the length equals. Then we need to figure out what the sides equal. let's say the height, right? So here's the height of my rectangle. I guess that since this is a distance, we should actually say this is another length. But let's see what the length is here. 2, 4, 6, 8, 10, 12, 14, 16, 18. So that's going to give me 18 plus 18, which equals 36, right? 36? Yeah, 36 units. And then I have to add my two heights with my two lengths. So I'm going to get 36 here plus 26, which equals 62. So the perimeter of Busby County is 62 units. Everybody see that? What I wrote there at the bottom? Sorry about that. There you go. So again, the perimeter of Busby County is 62 units. And to find the perimeter, I simply went all the way around my rectangle and counted up my units. All right, I'm going to slide my book up here. Let's take a look at number 3. Okay, so here we are on number 3 at the bottom of the page. Number 3, on a coordinate map of Melville, a pizza restaurant is located at -9, -5. A laundry business is located 3 units away to the left of the pizza restaurant on the map. What are the map coordinates of the laundry business? So what they're asking us to do here is plot point -9, -5, and then move 3 units to the left of the pizza restaurant. So what I did was I'm going to slide my book here, and I'm going to focus in on my coordinate plane that I drew. There we go. Kind of tough to see, but hopefully you guys can see the numbers there. Yeah, I think you can. Okay, so there's my coordinate plane. And what I'm going to do is I've got some colored pencils here, and I'm going to pick one of my colored pencils, and I'm going to plot -9, -5 on my graph. So I go across to the left -9 and down to -5, and here we go. So this is the location of a pizza restaurant. So I'm going to just label this point P. It says the laundry business is located 3 units to the left. So I'm going to label that with an L. All I have to do is move 3 places to the left. Now mine are in increments of 2, so it's 2, and then in the middle here is 3, and that's going to be the laundry business. Now the coordinate points for point B were -9, -5. Now that I've moved 3 points to the left, my coordinate points are -11, -5. So that's going to be the coordinates of my laundry business. So I'm going to come back here to my textbook. Slide my textbook down here. And I'm going to write in for my answer -11, -5. Let's read number 4. Number 4 says the library is 4 blocks north and 9 blocks east of the school. The museum is 9 blocks east and 11 blocks south of the school. How far is it from the library to the museum? Now the hard part about this question is they never tell us where the school actually is. Again, if we read it, it says the library is 4 blocks north and 9 blocks east of the school. The museum is 9 blocks east and 11 blocks south of the school. How far is it from the library to the museum? So again, they don't tell us where the school is. So in this case, I'm going to go back to my map here, or back to my coordinate plane. In this case, we're going to assume that the school is at the origin. And then we're going to plot the points of both the museum and, what else were we talking about? The library from the origin point. So I'm going to grab some different colored pencils. I'm going to use the same coordinate plane that I used to plot the last problem. And I'm just going to use a different set of colored pencils to help differentiate number 3 from number 4. So in this case, it looks like I have green. All right, so it says again, the library is 4 blocks north and 9 blocks east. So let's think of the top up here of our y-axis, can you guys see that in the camera, as being north, which would make the positive section on my x-axis here east, the negative section of my y-axis is going to be south, and the negative section of my x-axis here is going to be west. So again, I have north, south, east, and west. Now it says the library was 4 blocks north, so I'm going to go 4 blocks north, and 9 blocks to the east. So I'll come over here to 9 blocks to the east, and I'll plot that point. And I'm going to label that L for library. The museum is 9 blocks east, so again I'm going to come here 9 blocks east, and 11 blocks south. So now I'm going to come down south 11 blocks and plot that point. And I'm going to label this M for museum. So the points here, my 2 coordinate points, if I were to label my coordinates, would be 9 for L, would be 9, 4. And my coordinate points for M would be 9 and 11. I'm sorry, negative 11. So I've gone from 9, 4 to 9, negative 11. This to solve this problem, I can think back to section 3.9 when we were talking about distances between 2 points. And if you remember, we can take the 2 coordinate points and compare the 2 that change. So in this case, it looks like our x coordinates stay the same. Our y coordinates change from 4 to negative 11. So I want to compare those 2. So let's go back here to my textbook. And I'm going to take, since I'm in opposite, what do we call these? That's right, quadrants. We're in opposite quadrants. This is going to be an addition problem. And I'm going to add the absolute value of my 2 y coordinates, because those are the coordinates that are changing. So I'm going to take the absolute value of 4 and the absolute value of negative 11, and that's going to give me 15 units. In this case, the units are what? And in the problem, it tells us that the units are blocks. Sorry, I've been writing up here in my book. So again, I took the absolute value of 4. Let me zoom in here a little bit for you, see if you can get a better view of that. There you go. So I took the absolute value of 4 and I added that to the absolute value of negative 11, and I got 15 units. In the problem, it said that units are blocks, so this is going to be 15 blocks. And that's going to be the distance from the library to the museum. Let's do one more problem. I'm going to flip the page to 138, and I'll see you guys in a minute. Okay, so here I am on page 138, and I want to look at number 5. Number 5 says, Diane left her campsite at coordinates 2, 6 on a map of Big Trees Park, hiked to Redwood Grove at negative 5, 6, and continued on to Bass Lake at negative 5, negative 3. Each unit on the map represents 1 kilometer. How far did Diane hike? So we're going to have to plot these points. So I'm going to get my coordinate plane out again. So I'm going to slide my textbook up here, get my coordinate plane out, and refocus the camera a little bit so it makes it easier for you guys to see. All right, there's my coordinate plane. And this time I think I will use a brown colored pencil. So I've used red, I've used green, I'll use brown this time. So let's see where her campsite was. It says Diane left her campsite at 2-6 on a map of Big Trees Park. So let's plot 2-6. So here's 2, here's 6, and we're going to mark this with a C for campsite. Everybody see that? The next place that she hikes to, or she hikes from her campsite to Redwood Grove at negative 5, 6. So let's plot negative 5, 6. Here's negative 5 up to 6. And I'm going to label this RG for Redwood Grove. From Redwood Grove, she continues to Bass Lake at -5, -3. So here's -5, and I'm going to come down here to -3. And this is, I'm going to label BL for Bass Lake. So she travels from C to RG, or campsite, to Redwood Grove. And then from Redwood Grove, she hikes down to Bass Lake. So what we need to do is figure out what these distances are. So I'm going to come back up here to my textbook, and we can do some of this math. All right, so here's my textbook, and I'm going to work in the show your work area here. So to go from the campsite to Big Trees Park, if I look at those two coordinates and I look at the numbers, it looks like at first from campsite to Big Trees Park, my Y values stay the same, but my X values change. Are we doing an addition problem here, or are we going to do a subtraction problem? Well, are we changing quadrants, or are the quadrants staying the same? These quadrants are changing. So I'm going to do an addition problem between my X value 2, the absolute value of 2, and the absolute value of -5, and that's going to give me 7 units. But then Diana hikes from Redwood Grove to Bass Lake. And in this case, the X values stay the same, but my Y values change from 6 to -3. So I'm going to take the absolute value of 6 and the absolute value of -3, and I have to decide, am I adding these together or am I subtracting to find out how many units Diana moved? And these are going to be different quadrants, so again, I'm going to add those together. So 6 plus 3, that's going to give me 9 units. So again, she traveled from her campsite to Redwood Grove, that was 7 units, and then Redwood Grove to Bass Lake, that was 9 units. And we need to figure out how far in total she hiked. So we're going to add 7 plus 9 units, and that's going to give me 16 units. Up here in the problem, it says that each unit on the map represents 1 kilometer. So therefore, if she hiked 16 units, she hiked 16 kilometers. All right, that's going to end our lesson today, lesson 3.10. Congratulations, you guys have finished the flipped class of chapter 3. The next flipped class will focus on chapter 6. And so I'll see you guys in chapter 6. In the meantime, enjoy your chapter 3 test. Mr. Hassan, signing off.
The key is that the person at the back of the line who can see everyone else's hats can use the words black or white to communicate some coded information. So what meaning can be assigned to those words that will allow everyone else to deduce their hat colors? It can't be the total number of black or white hats. There are more than 2 possible values. But what does have 2 possible values is that number's parity. That is, whether it's odd or even. So the solution is to agree that whoever goes first will, for example, say black if he sees an odd number of black hats, and white if he sees an even number of black hats. Let's see how it would play out if the hats were distributed like this. The tallest captive sees 3 black hats in front of him, so he says black, telling everyone else he sees an odd number of black hats. He gets his own hat color wrong, but that's okay, since you're collectively allowed to have one wrong answer. Prisoner 2 also sees an odd number of black hats, so she knows hers is white and answers correctly. Prisoner 3 sees an even number of black hats, so he knows that his must be one of the black hats the first two prisoners saw. Prisoner 4 hears that and knows that she should be looking for an even number of black hats since one was behind her. But she only sees one, so she deduces that her hat is also black. Prisoners 5 through 9 are each looking for an odd number of black hats, which they see, so they figure out that their hats are white. Now it all comes down to you at the front of the line. If the 9th prisoner saw an odd number of black hats, that can only mean one thing. You'll find that this strategy works for any possible arrangement of the hats. The first prisoner has a 50% chance of giving a wrong answer about his own hat, but the parity information he conveys allows everyone else to guess theirs with absolute certainty. Each begins by expecting to see an odd or even number of hats of the specified color. If what they count doesn't match, that means their own hat is that color. And every time this happens, the next person in line will switch the parity they expect to see. So that's it, you're free to go. It looks like these aliens will have to go hungry, or find some less logical organisms to abduct.